right, so continuing our discussion about the sine graph, let's just look at what happens. We saw what happened before, when we multiply the outside by a number. So what happens when we multiply the inside by a number? In other words, what happens if we manipulate the angle? So remember that this right here is an angle. Whenever you apply a trig function to something, that something is an angle, okay? So we already know that the graph of y equals sine of x completes one full cycle between x equals 0 and x equals 2 pi. That we know, okay? What do we have the graph of sine of bx? Well, we know that bx is the entire angle. This is just how we write it because it just kind of looks prettier, right? We try to avoid using parentheses when possible because, that space is just expensive, right? So completes one full cycle. Well, so the angle has to go from bx equals 0 to bx equals 2 pi. Well, wait a minute. That means that corresponds to x equals, well, if I divide by b, I'm going to assume that b is not 0. That means x is equal to 0. And if I divide both sides of the other equation by b, I get 2 pi over b. Well, great. One full cycle. X equals 0 to x equals 2 pi over b. So that tells you that the period of this graph right here, y equals a sine of bx, so the amplitude has nothing to do with the period. It's just going to be 2 pi over b. And we're always assuming that b is positive. We're not going to face a negative b here. So let's see how we handle this in some examples here. So I know what sine of x looks like. What does sine of 2x look like? Well, let's see. So the period is 2 pi over b, which is 2 pi over 2, which is pi. So that means this thing is going to swing through one full revolution in pi units, okay, as opposed to 2 pi. So it's going to look very squished, probably. Now let's just look at, and notice that the amplitude is 1 because there's no number in front of it. So what I'm going to do is I'm going to draw my y-axis here, okay? I know that sine starts at 0 and ends at 0 after one full period. I know that between the two outer intercepts, there's an inner intercept. And I know that between two consecutive intercepts is either a max or a min. I know sine starts out by going up. So here's its max value at 1. There's its min value at -1. And I'm going to draw a couple more swings of this just so we get the full effect of what's happening here. Up, down, up, down. So, whoops, always wants to erase. So there's my graph. And that's just going to keep on riding. Okay, so there is a couple periods of sine of 2x. Okay, so again, whenever your angle is multiplied by something, that's going to affect how often it repeats. Okay, so with that said, and then we're going to get into cosine here. So this is going to be a shorter. Oh no, we have two of those. Okay, good. Write the equation of the following curve, assuming an equation of the form mat. Okay, so notice this is a sine curve because it starts at 0, 0, and it goes up on one side, down on the other. So we're good there. All we want to know are the pieces. So looking at this, the period of this graph appears to be pi over 3 because it repeats itself after pi over 3 units. The amplitude, remember how we compute amplitude, is the distance between the center and one of the high points, and that looks like 4 here. So we already know that A is 4. Now you don't rush to say B is pi over 3. That's not correct. We know the period is pi over 3, which is 2 pi over B. So if pi over 3 is equal to 2 pi over B, the question is, what is B? And it looks like 6 pi is equal, I'm sorry, not 6 pi. It looks like B pi is equal to, oh, it was 6 pi. B is 6. Well, then that's weird because they look the same. So that means B is equal to 6. So what is my equation? I know that A is 4, so that's going to be 4 sine, and I know that B is 6, so 6x. And there's the equation of the curve. All right, let's look at another one. So again, this is starting at 0, 0 and heading upwards. So I know that this is a sine graph again. And I notice that it goes through one full cycle after 4 units. So the period itself is 4. The amplitude, well, it looks like it goes up to 0.25 and down to negative 0.25. So I'm going to say the amplitude is 0.25. And now I can put these pieces together to get the equation of the curve. I already know that A is 4, so that's 4 sine. And I know that not 4, sorry. I know that this is 0.25 sine. Now, I need to know what I'm multiplying by x. Well, I know that 2 pi over b is the normal period, is the period of the graph. And in this case, I want the period to be 4. Well, if I multiply both sides by b, I get 2 pi equals 4b, which means b is equal to 2 pi over 4, which is pi over 2. And there we have it. There is the equation of the graph that's in the picture. So as you can see, if you know those key concepts, you can find the equation of the graph if I give you one. So that's going to be part of what we do. We have, we're going to be given a situation in nature. We know it goes up to this, down to this, whatever. Can we write its equation? And this is going to be one of the couple ways that we can do so. So that wraps up sine. We're going to look at cosine and apply all these concepts. And then we're well on our way to understanding what the graphs of these things look like. So stay tuned. Thanks so much for watching.